Hello and welcome. In this video, I'm going to examine BGP route reflector in multiple scenarios. In the first scenario, what I'm going to do is to configure IBGP connections inside AS100. And I'm going to, first of all, configure router 2 and router 5 as route reflectors. And then I'm going to examine what is going to happen in case, for example, these routers are route reflector clients to router 2 and these routers are route reflector clients to router 5. And after that, I'm going to do something else. What I'm going to do is to make sure that router 2 and router 5 are going to be in the same cluster. Then I'm going to configure router 4 and 7 in the second cluster, and I'm going to say router 1 is going to be a client to this, router 3 a client to this, and also router 4 is a client to this, router 7 is a client to this, router 6 is going to client to router 4, and router 7 of course. So two different scenarios in which I have multiple clusters or in multiple routers in the same cluster. So let's start the configuration. This is completely greenfield configuration, so I'm going to start from router 1. On router 1, I'm going to say configure terminal, router BGP, I'm going to say router BGP 100. And for router BGP 100, you can see that I have an adjacency with router 8. So I'm going to say neighbor 10188 is in remote AES 200. And that is one of the neighbors. And now, like I said, I'm going to be a route reflector client to router 2. So the only thing that I'm going to have is neighbor 2222 in remote AES 100. And I'm going to use my loopback 0, which is 1111 as my update source. Under address family IPv4 unicast, I'm going to say neighbor 2222 activate, neighbor 10188 activate, and also I'm going to advertise my loopback into BGP table. So I'm going to say network 1111 is /32 is going to be under this. So let's commit this configuration and end and save. The same thing on router 3 of course should happen, but router 3 is a route reflector client to router 5 only. So on here I'm going to say configure terminal, router BGP 100. There is an adjacency between router 3 and router 9, so I'm going to say neighbor 10399 is in remote AES 200. Also neighbor 5555 is in remote AES 100. And for this, I'm going to use my loopback as update source. So let's go to address family IPv4 unicast. And under this, I'm going to activate each one of these. This should be activated. This should be activated. And finally, my network 3333/32 should be advertised. So I'm going to commit the configuration and end it and save it. Okay, let's go to router 2 and do the configuration on here. On router 2, what I'm going to do is to say configure terminal, router BGP 100, router BGP 100. I can use a peer group to facilitate the configuration. That is a good idea because I have multiple neighbors here. So what I'm going to say is to say neighbor clients, and I'm going to say peer group. Neighbor clients are going to have an update source of 2222. They are going to be in remote AES of 100. And they are going to be route reflector clients. So I'm going to activate them later. But let's say that neighbor 1111 is going to be part of this peer group clients. So neighbor 4444 is going to be part of this, and also neighbor 6666 is going to be part of this. Neighbor 6666 is going to be route reflector client for two different route reflectors. Let's go under address family IPv4 unicast. Here I'm going to say neighbor clients activate, and neighbor clients is going to be route reflector client. And also let's advertise a network of 2222/32 into BGP. Commit the configuration, and here is a problem that says configure peer group first, and I have configured peer group first. So it says that neighbor clients update source, and after that you see that that is a problem because I have forgotten to have S in here. Okay, so I'm going to say no problem, exit here, no this one, no this one, but this one, also this one should be negated and have an S in the end, and this one, no this, but this. Now if I commit, I will have no problem. Okay, let's go to the rest of the configuration. On router 4, I'm going to do the configuration. On router 4, I'm going to say configure terminal router BGP 100, and I'm going to say neighbor 2222 remote AS 100 with an update source of 4444, and under address family IPv4 unicast, I'm going to say this network, this neighbor should be activated, and also I'm going to have a network of 4444/32 and commit the configuration. Let's do the same configuration on router 6, and then I'm going to examine something before continuing to the other side. So on router 6, I'm going to say configure terminal router BGP 100, and I'm going to say neighbor is going to be 2222, and address family on remote AS 100, and finally update source of 6666. Under address family IPv4 unicast, I need to activate this network neighbor, and then network of course is going to be advertised as well. Okay, if I just commit the configuration and go to router 2, and I'm going to say show IP BGP summary. Now you can see that I have adjacencies with router 1, 4, and 6. This is the expected thing. And if I just go with any of them, let's say for example neighbor 6666, and check that, it says that route reflector client is configured for this specific neighbor. This means that if I just go to router 6 and say do show IP BGP, then I should see almost everything that we have it here. And if I just go with this specific prefix, for example, it says that I have received it from router 2 with a cluster list of 2222. And the reason for this is I have not configured any cluster ID. So this is going to use the router ID as a cluster ID. Okay, so what we have done here is we have just configured a path to here. And in this, router 1 was a route reflector client, 4 and 6 are route reflector client here. Now without this configuration, what would happen if I wanted to reach to something on AS200? What would happen is 10.10.10.10 would be advertised to router 8. Router 8 would advertise it to its eBGP neighbor, default behavior. router 1 has received it from an eBGP neighbor, would advertise it to, let's say, router 2. And router 2 has received it from an IBGP neighbor, so it would not advertise it to any other router. So we will have kind of no information about 10.10.10.10 on router 4 and 6. But now the thing has changed. We just said that router 1 is a route reflector client to 2 and others, of course. Even if router 1 was not a route reflector client, the default behavior for non-client for a route reflector was to receive from non-client, but not advertise to non-client. But here it's a client, so it's going to receive, and after that, router 2 would advertise it to router 4, would advertise it to router 6, so they now know about what is happening. Now, let's do the rest of the configuration. This time, what I'm going to do is to say, okay, we can have reachability to AS200 from router 6. What I'm going to do is to say, this time I have a cluster of route reflectors. I'm not just using router 5 or router 2. I'm not configuring router 5 because the same configuration that goes on router 2 is going to go to router 5. So nothing is special about that. What I'm going to do is this time is I'm going to say these two routers are going to be in the same BGP cluster, a route reflector cluster. These are going to be the same cluster, and now I'm going to examine what is happening on router 6. So let's do this configuration. So far what I have done is this configuration, and I'm going to go to router 2, and I'm saying that on router 2 configuration, on router BGP 100, I'm going to say BGP cluster ID is going to be 25, 25, 25, 25, and hit enter and commit the configuration. Okay, now I might add some more routers to this cluster. Later I'm going to show you how. So let's go to router 5 and do the same configuration, and then start the configuration of the neighbors. On here I'm going to say router BGP 100, and I'm going to add this. And because this is going to be again multiple, not multiple, of course, I'm going to have only 2 route reflectors. I'm going to change the configuration on router 2 later, but I'm just going to show you that router 5 is going to have router 3 as its neighbor. So I'm going to say neighbor 3333 is in remote AES 100 with an update source of 5555. Then I'm going to say neighbor 7 is in remote AES 100 with an update source of loopback, which is going to be 5555. And finally router 4, of course. I'm going to configure router 4 as a client to router 5. So neighbor 4444 is in remote AES 100 with an update source of loopback. Okay, now I should activate that under address family IPv4 unicast. So neighbor 333 activate, and route reflector client neighbor 7 activate, and route reflector client and neighbor 4 activate, and route reflector client. So, and also I'm going to advertise my own loopback interface. Okay, let's commit the configuration and then save. Now let's go back to router 2 and change the configuration a little bit. On router 2, what I'm going to do is to say show run router BGP. Now under this router BGP, I'm not going to have router 6 as my route reflector as my neighbor. So I'm going to say no neighbor 6, 6. On router 2, I have 4, I have 7, and I have 1. So 1 is already there, 4 is already there, so 7 is going to be added. So what I'm going to say is neighbor 7777 peer group clients. And this is already activated, so that's going to be okay. So no problem, just commit the configuration. So what I have done so far is this. I put these two in the same cluster. Then I said that this router 3 is a client, is a neighbor to this, and this. And also I have this router 1 and router 4 and router 7 as clients to this. So this is so far my configuration. What I'm going to do is to create the cluster 47 as well. And 47 is going to be route reflector for router 6. So let's go to router 4. On router 4, I'm going to say show run router BGP. So go to configuration mode, go to router BGP 100, and I'm going to say BGP cluster ID is going to be 47, 47, 47, 47. Okay. Router 4 should be neighbor to router 2, which is already is, and also router 5. So I'm going to say neighbor 5555 is in remote AS 100 with an update source of 4444. And later I'm going to activate it, and also router 6. So I'm going to say neighbor 6666 is going to be my route reflector client. So let's say remote ASA 100 update source of 4444. Let's go under address family IPv4 unicast. This router 6 should be a route reflector client. This neighbor should be activated as well. And also this neighbor should be only activated. This is not a client. So I'm just going to commit, and after some time I'm going to show you the configuration completely so that you can understand everything. On router 6, I'm going to on router 7, let's just do the configuration. On router 7, show run router BGP. I have not configured router BGP on this. So what I'm going to do is to say router BGP 100 BGP cluster ID should be 47, 47, 47, 47. Okay. My neighbors are going to be router 5 in remote AS 100 with an update source of 7777. The other neighbor would be router 2. And the other neighbor would be router 6. Okay, I have this. I'm going to go under address family IPv4 unicast. Then I'm going to say this should be activated. This should be activated. 6 should be activated. And 6, of course, is a route reflector client. And let's say I'm going to have network advertise. Okay, the only thing which is left is router 6. I should change the adjacency on router 6 to 4 and 7 only. So I go to router 6, show run router BGP. For now, this is our configuration. And I'm going to say router BGP 100. So this neighbor is no longer active in remote AS 100. But I'm going to have neighbor 4444 in remote AS 100 with an update source of 6666, and neighbor 7777 is going to be in remote AS 100 and with an update source of 6666. Under address family IPv4 unicast, I'm going to activate these neighbors. So this one activated and this one activated. And also let's advertise 6666. Commit the configuration. Okay, so far what I have done is this. I configured this adjacency between router 3 and 5 as a route reflector client. Also 3 as a route reflector client to router 2. 1 is a client to router 2 and a client to router 5. These two are in the same cluster. Okay, and also I have 7 as a route reflector client to 5 and 2. 4 is a route reflector client to 5 and 2. Now I have another cluster here, which I have 6 to that and 7 to that. This is what we call it a hierarchical route reflector solution, in which we just make sure that the number of clients are not too high, and we are just managing the number of clients. Now, of course, I don't have so many routers in here, but if you go over 20, 30 routers, then this should be the best way to configure route reflectors. Now, let's examine everything. I'm just going to check the configuration, and then I'm going to verify everything. So on router 1, let's say that I'm going to say end on all of these, and I'm going to save it. Then I'm going to say show run router BGP on all routers. So on router 1, I have adjacency to 2 only. And I could just configure router 5 as well, but I just decided that I have this one, so I am not adjacent with router 5. That's okay. Router 3 is only router part. 2 has 147, which is okay. 5 has 347, which is correct. 6 has 4 and 7. And 4 has 265, that's okay. And 7 has 265, that's okay. Now if I go to router 6 and say show IP BGP, now you can see that again I have access to every routes. If I say show IP BGP 10, 10, 10, 10, it says that I have received it from 2 different ways. Of course, both of them are advertising XSUP of 10188 because this is the best path for us. But the cluster list is this. It has gone through 25, 25, 25, 25, and then through 47, 47, 47, 47. And that is why we are receiving only one, because both of them are cluster and they are seen from the viewpoint of one of them, and only one base path is going to be advertised, which is this one, and they have advertised this to us. So the second cluster has received that and it has advertised it to us because it has no other way of understanding this. And the other thing that I should say is I have not configured max path, or I have not configured multiple base path installation, which I'm going to configure it in another video. But for now, the only important thing is we have these clusters configured, and through those clusters we can receive the best path to the destination. So I hope this has been informative for you, and see you in next videos.